Welcome back everyone, Patrick here, moving on to the next question dealing with circles. So we are given the endpoints of a diameter in a circle and they're -5 and 3 and 1 and 7. And then what we have to do is we have to find the equation of the circle. Then in part B we have to find another point on the circle. And then in part C we have to verify that the point in part B and the two endpoints of the diameter that are given form a right triangle. And that's actually a theorem. It's called Thales or Thales Theorem. There's different pronunciations that come up. So that's what we're going to verify. We're going to verify that theorem in part C. So before we get into the actual algebra, let me visually show you what's going on. So what's going on is we have a circle that is given, and then we're told the endpoints of a diameter are given. So let's say over here this is like -5 and 3. By the way, this is not going to be to scale, so you can draw these on a Cartesian plane if you want. I'm just drawing them here just as a rough drawing so we have something to refer to, but the location of these points is going to be different if you draw it on a Cartesian plane. Now, a diameter, you got to be careful, it's different than a chord. Remember, a chord is basically any 2 points on a circle that can connect, right? And a diameter is a type of chord. But a diameter, more specifically, it has a restriction that it has to go through the center of the circle, right? So it's basically the longest line that can be created within the circle if you join two endpoints. So if we say the center of the circle is there, right, the diameter would, for example, be like that. This is not to scale, but the center of the circle, it's actually going to be the midpoint of the diameter. And so that's what we're going to be doing. We have to first find the midpoint of the diameter, and that's actually going to be the center of a circle. So any diameter that you draw on a circle, its midpoint, it's always going to be the center. So that's what we're going to do to find the equation. Now, sometimes you'll be given information about the endpoints of a diameter. There may also be a question where maybe you'll be given two equations of a diameter, of two diameters, and maybe you have to find the point of intersection between them, and where they intersect is also going to be the center of that circle. So there's different kinds of questions that you could get when dealing with a diameter. In this specific case, we're just given information about one diameter, right? The endpoints of one diameter. And so we're going to use those endpoints to find the midpoint, and that's going to be the center of the circle. But another popular type of question is if you're given two diameters and you're given the equations of them, where they're going to intersect is going to be the center of the circle. Okay, so just be on the lookout for those. So we're going to find the midpoint. That's going to give us the center, and once we have the center of the circle and we have any point on the circle, we could find the equation as we've done in previous videos. Now, what we're going to do in part B is we're going to find another point on the circle. So it's just going to be any point. It's going to be a random point, right? We're going to find another point on the circle. And then in part C, what's going to happen is we have to show that the triangle that's formed with the endpoints of the diameter and that other random point that we find, so if we draw a triangle here, that it's going to form a right triangle like that. And then the diameter is going to be the hypotenuse. So that's what Thales Theorem is that just in general, if you draw any diameter, okay, so let's draw a different diameter, a different shape, let's say like this. If you take any diameter and then you take any point on the circle, so could be here, could be here, could be here, and then you create a triangle, that triangle is always going to be a right-angled triangle. That's what the theorem is, right? So if we create a triangle at this point, or if we create a triangle with this point, okay, or if we create a triangle with this point, right? The triangle that's always created with any diameter of the circle and then any point on the circle, it's always going to be a right triangle. That's what the theorem states, and that's what we are going to confirm with this specific circle, right? So that's a brief overview of what we're going to do visually. So let's first, in part A, find the equation of a circle. Now, remember the equation of the circle, if a circle has a center at h and k, the equation of it is going to be x minus h squared plus y minus k squared is equal to the radius squared. So let's first find this h and k. As I mentioned, it's going to be this point. It's going to be the midpoint between the two endpoints. So the midpoint is going to be the sum of the x values divided by 2, and then the sum of the y values divided by 2. So what we would do is we would take -5 plus 1, divide that by 2, and then we'll take 3 plus 7. And we're going to divide that by 2. So this would end up being -4 over 2, and then we'll have 10 over 2, which would give us -2 and 5, like that. So the center of the circle in this case is -2 and 5. And now we have enough information to find the equation of the circle. So what we can do, let's put this point here. So the h is -2, the k is 5. So we would have x minus the h value, which is -2. Be careful with the brackets here. That's going to be squared. Then we'll have y minus 5. That's going to be squared. And then we're going to have r squared. So this here we would rewrite as x plus 2 squared plus y minus 5 squared is equal to r squared. And now all that's remaining is to get the radius. Different ways you can get it. You could find the length between this point and this point, or you could find the length between this point and this point. You could also find the length of the diameter divided by 2. Another way to do it is you could take any point on the circle, so either of these 2 points, plug them in here, and then isolate for the r. So that's actually what I'm going to do. And I'll plug in 1 and 7. So I'll plug in 1 for x, and then I'll plug in 7 for y. So whichever way you find the radius, just make sure you're getting the same radius. Now be careful, you can't plug in this point for x and y here. This x and y that you plug in, it always has to be a point that's on the circle. So either -5 and 3 or 1 and 7, you're going to end up getting that same value for r. So in this case, we'll have 3 squared plus, what would this be, 2 squared? So we'd have 9 plus 4. So r squared is equal to 13. So the radius is root 13. They didn't ask for the radius though, they asked for the equation, so you could actually just plug in 13 for the r squared. Okay, so writing the equation out over here, we would have x plus 2 squared plus y minus 5 squared, and then r squared is that value of 13. And so that there is the equation of a circle that has a diameter with those endpoints. Okay, so part A, we are done. Now what we got to do in part B is find another point, right? This point over here, that's going to be on the circle. And so to find another point, what you can do is you could either plug in something for x or something for y, right? Any of those values, and then you could isolate for the other one. So what I'm going to do, an easy point to usually pick is a value of 0, right? Either for x or y. Now notice that you can't plug in a value of 0 for y. So let me just first start with that, because a lot of times that's what's going to happen. Notice that if we have 0 minus 5 squared, and then that's equal to 13, we'll have x plus 2 squared plus -5 squared. So we'll have x plus 2 squared plus 25 equals 13. Notice when we bring the 25 over, 13 minus 25 would give us -12. And we can't square root, right? To isolate for this x, we'd have to square root at this point. We can't square root a negative number. So what that means is that there's no point on this circle that's going to contain a y value of 0. If you ever get to this point where you have to square root a negative, then you got to go back and pick another point, because that point, that value you plugged in for either the y coordinate, like in this case, or the x coordinate doesn't work out, right? So what we got to do is pick another point. So 0 for y wouldn't work. Now, what if we plug in 0 for x? And by the way, it doesn't have to be necessarily 0. You could try 1. I don't think a y value of 1 would work, right? Because you'd end up with 16 over here. If you bring it over, it becomes negative. But an x value of 1 would work, because when you would bring that over, it would be positive. Okay, so sometimes you got to play around a bit, but what I'm going to do is I'm going to pick an x value of 0. Let's see what we get when we do that. So this would end up being 4, right? 0 plus 2 is 2 to the power 2 is 4. So we'll have 4 plus y minus 5 squared equals 13. Bring this over, so we'll have y minus 5 squared equals 13 minus 4, which would be y minus 5 squared is equal to 9. Okay, and now we could square root both sides, and it's nice because a lot of times when you square root here, you're going to get a decimal number, but in this case, root 9 is smooth. Now, there's actually two solutions because the square root of 9, it's either plus or minus 3. So we can either say y minus 5 is equal to positive 3, or y minus 5 is equal to negative 3. Right, so y can either be 8, or y can be negative 3 plus 5, which would give us 2. So there's actually 2 points on this circle that have an x value of 0. So either 0 and 8 or 0 and 2. Right? 2 different possibilities. So we only have to pick one of the points for part C to use, but you could use either of these, and either of these points, if you pick it here, it's going to form a right triangle, right? So both of these points here, they lie in the circle. I'm going to just use 0 and 8, but you could also use 0 and 2 if you want. All right, so we found another point on the circle, and it's nice. A lot of times, again, you're going to get decimals over here, but in this case, it was integers, so that was nice. So we got 0 and 8. That's the point I'm going to use. And now what we got to do in part C is verify that the triangle formed between these 3 points is a right triangle. So there's multiple ways to do that, as we've gone through videos before when we dealt with triangles. One way is we could find the slope of this line, find the slope of this line, and then see if they're negative reciprocals of one another. And if they are, then it means that there's an angle of 90 degrees between them, that they're perpendicular. The more common way is to find the lengths of all 3 sides and then show that the Pythagoras theorem holds, right? Because with a right triangle, any right triangle, the hypotenuse is C, then we have A and B for the other sides. We know that A squared plus B squared has to equal C squared, right? If A, B, and C are the lengths of the triangle. So I feel like this method's a little longer, and that's actually the one I'm going to go through just because it's the more popular, quote-unquote, proper method. But another method, if your teacher allows it, is you could find the slopes of all the sides. And then if 2 of the sides, it should be these 2 sides here, right? Because the 90-degree angle, remember, Thales Theorem says that the diameter is always going to be the hypotenuse. So it's really these 2 sides you got to find the slopes of. If they're negative reciprocals, as they should be, then they're perpendicular, and you show that there's an angle of 90 degrees between them. But what I'm going to do is I'm going to find the length. So what I'll do is I'll actually label these. I'll label this A, B, and then C. So let's first find the length of AB. Okay, the length formula is root x2 minus x1 squared plus y2 minus y1 squared. So I'll label this x1, y1. I'll label this as x2, y2. Yeah, so we'll have x2, which is 0, minus x1, which is negative 5. Be careful with the brackets here, plus y2, which is 8, minus 3. We're going to square that, so this would end up being 0 minus -5 is like 0 plus 5, right? Those two negatives become a positive, so we'd end up with positive 5 squared plus positive 5 squared. So we'd end up with 25 plus 25, which would give us root 50. And I'm going to leave it as an exact value. Okay, so the length of AB is root 50. Now let's find the length of BC. So that's going to be this over here. We have this x2, y2, so I'll label this as x1, y1. So what we're going to plug in now instead is this x1, this y1, the x2, the y2, right? They're staying the same because we're still using that point B. It's just now the x1 is going to be 1, and then the y1 is going to be 7. So we would end up with what over here? -1 to the power 2 plus 1 to the power 2, which would basically give us 1 plus 1, which would give us root 2. All right, so the side BC has a length of root 2. And then finally, let's find the length of AC. So we already have the x1, y1 here, so I'm going to change this coordinate A to be x2, y2. So we have the x1, y1, right, the 1 and 7. Now we're going to plug in a new value for x2, which is -5, and then y2, which is 3. So what would we get here? We'd end up with -6 squared plus -4 squared, like that. So this would end up being -6 to the power 2 is 36, -4 to the power 2 is 16. We'd end up with root 52, like that. Okay, so AC is equal to root 52. And you could tell already from here that when we plug it into that Pythagoras theorem that it should hold, because notice, remember, for a right triangle, a squared plus b squared is equal to c squared. Remember, the c always has to be the hypotenuse, and then the hypotenuse is always going to be the diameter, right? If you create a triangle like this. So we know the c here is basically this length, this root 52, right? It's the larger length. So we'll have root 52 squared. Then the a and b, it doesn't matter which one you label. So we'll have root 50 squared plus root 2 squared. Root 50 to the power 2 is just 50. Root 2 to the power 2 is just 2. Root 52 to the power 2 is 52. And then notice that we do indeed get the left side equaling the right side. And because we got there, then we verified that we're dealing with a right triangle. Okay, if you didn't get left side equaling right side over here, then you got to go back and check your steps. Something is wrong. Maybe with your algebra of finding the point, or maybe your algebra with finding the lengths, right? No matter what diameter you use on a circle and what point on the circle, those 3 points will always form a right triangle, right? That's the theorem, and we just verified it with a specific case.